Okay, last video. So what is the difference between direct and alternating current? So we talked about these two different types of current. With direct current, your electrons all flow in one direction. So a direct current is like from a battery source, and it's a short distance type current. It would be the type of current that's used for charging your phones or your laptops. And then alternating current, the electrons go back and forth, or they reverse direction. That's where alternating comes from. They alternate, they go back and forth. A voltage source for this would be something like a generator or a really big, like a power plant. And a typical use, alternating is the current we use for our households, for our school. So it's like a big power because it travels well over long distances. What's the purpose of a fuse and a circuit breaker? Okay, so in both cases, they're a safety device to stop a dangerous current. Stop a dangerous current level. So what a fuse, those are like the older type devices. A fuse melts, the inside of it melts when the current gets too hot or too high and shuts down the circuit. And then a circuit breaker trips or it flips off. And in both cases, what they're doing is shutting off a circuit. So stops a dangerous current level by shutting off circuit. So both of them, they work a little differently from each other, but they do the same thing. Okay, your refrigerator uses 800 watts of power each hour. Power company charges 11 cents per kilowatt hour. How much does it cost to run your refrigerator for 24 hours? Remember, this is where we're just multiplying multiple things together. So one thing I do need to do is convert watts into kilowatts for my refrigerator. So that's 800 watts. And I'm going to divide that by 1,000 because there's 1,000 watts in a kilowatt. That gives me 0.8 kilowatts. So that's my power rating for my refrigerator. It uses 0.8 kilowatts each hour. And then we're going to run it for 24 hours. And then it costs us 11 cents per kilowatt hour to do that. So that's going to be 0.8 times 24 times 0.11 is going to cost us $2.11 to run our refrigerator. So that's a pretty efficient refrigerator. But we're just multiplying the power rating by the hours. Remember, that's got to be in hours over which we used it times the time. All right, and then last question. We're worried about the environment, so we're shopping for an air conditioner. We want the most efficient air conditioner. So we're going to check out these two models, which would be the best choice. Okay, so we got model 1 uses 0.7 kilowatts of power, but it's got to run for 8 hours a day. Model 2 uses 1.2 kilowatts, but it only needs to run for 4 hours a day. So what we can do is just multiply our kilowatts by our hours for each of these and compare it. we're just assuming the same cost from the power company for each of these. So we're just going to really compare their kilowatt hour rating. So this one has 5.6. And let's see, 1.2 times 4. This one has 4.8. So actually, the model that has the higher kilowatt rating is going to be the best choice because it has a lower kilowatt per hour rating overall. Even though this value is higher, it needs to run for less time. And we got to multiply those two together. Then we multiply them by the cost, like we did here, to get our total cost. Here we're just comparing these two. So we can just get each of their kilowatt hour ratings, compare them, and the lower one is going to be our more efficient choice. So that is our study guide.